In this video, we are going to talk about discrete, domain, and range. Okay, so we're going to go over some vocabulary words before we do discuss what discrete and continuous are. So if we look here, domain is all of our x values. It is the independent variable. And it is also the input of our function. It's what we put into the function. Range is all your y values. It is the dependent variable. And it is also the output, of all of the functions. Okay, so dependent y in output versus x independent in input. Your words discrete and continuous are how the functions can be described. So a discrete function are very set in stone points that they're given. A continuous function might be like a line or a squiggly line or a parabola, okay? So the continuous is something that we'll go over in the next video, but today we're going to talk about discrete. So discrete and continuous are how functions can be described. All right. The domain and range of discrete relations can be represented in many ways. Okay, it can be represented in a table, mapping diagram, list of ordered pairs, or a graph. Okay, a table, your set of x's are your domain and your y's are your range. So if I asked you to list your domain of this table, it would just be 0, 2, and 4. And your range would be 3, 6, and 12. In the mapping, because your x and x's are on the left and your y's are on the right, or your inputs on the left, your outputs on the right. This is your domain. This is your range. For your list of ordered pairs, all of your first coordinates are your domain, and all your second coordinates are your range. And then your graphing, okay, so when we're looking at the graphing, I think it's easier to determine your domain when you're looking at it from left to right, like you're reading a book. And it's based on where it's at on the x-axis because our domain is our x values. Okay, so you're looking at the x-axis. So like this one right here would be -3 because the furthest left it goes on the x-axis is -3. And then so on and so on. You could go to the next one, it would be -1. Okay, your next, for range, it's like riding an elevator. So it goes from bottom to the top. And it's based off of where it's at on the y-axis because our range is our y ordered pairs or y coordinates. So you go from bottom to top. So like the most bottom one, these points get is at -4. But it's -4 among the y-axis. And same thing for the next one. The next one's at -3. And that's based off of where it's at on the y-axis. All right. Discrete relations where the domain is limited to whole counting numbers. It's always going to be a list or set of points. Okay. All of the examples you have seen so far are discrete. So the table, the mapping, the ordered pairs, or the graphs with points on them. If your function is represented in a list of ordered pairs, a table, or mapping, the best way to list your domain and range is using brackets. Always list the domain and range from smallest to largest and do not repeat numbers. Biggest key right here. And do not repeat. So that's why it's always, for domain, it's always left to right versus right to left, because your furthest left number will always be the smallest. So this is a set of ordered pairs. So when we have a set of ordered pairs, when we write our domain, it's always the first ordered pair. So, and we have to put it in numerical order, so smallest to largest. So it's 0, 1, 2, 3. For our range, because range is your Y ordered coordinate, you're going to use the second part of the ordered pair, and you must put it in number order. So -5 will go first, and then it's 2, 8, 10. And then we need to determine if this is a function. Yes, this is a function because all x's are unique. We don't want to repeat our x's, remember, because that relation is not functional. All right, write the domain and range of the following. Okay, so this is where I'm going to rely on domain goes from left to right. And it's based off of the x-axis. Okay? So my x-axis is right here. And then I'm just going to go from left to right. So this first point right here is at -3. This point right here, if we're looking at the x-axis, is at -1. This point right here is at 1. This point's at 2. This point's at 3. And so is this point. Okay, notice how I've started my ordered pairs. Okay, so now I'm just going to list them in order from left to right. So my furthest left one is -3. Furthest -1, 1, 2, and 3. Notice how there's 2 3s. But if we remember in our description, we do not repeat numbers. So because we do not repeat numbers, listing our domain is done. Okay, so remember our range is from bottom to top, and it's based off of where it's at on the y-axis. Our y-axis goes up and down. So the furthest bottom is this point right here. Okay, and that's at -4. So our first number is going to be -4. Our next one is this point right here, and that's at -3. We go up, 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 up. I don't hit another point until I hit this one right here, and that's at +1. The next one I hit is 3, 2. Then I hit 3, 4. And then my last one I hit 5. Okay. You also could have just labeled all the points at first and done the same thing we did over here with the ordered pairs. Once you have all your ordered pairs, you can highlight which one your x's are and then just put it in numerical order. I like to go domain left to right, range bottom to top, because it's going to be the same method when we're doing continuous domain and range. All right, is this one a function? No. Okay, the reason why it's not a function is because of these 2 points right here do not pass the vertical line test. All right. So since these functions are all discrete, they are just specific points, not continuous. We have to list the values of our x's and y's. All right, so domain and range. Domain is your x values, left to right, on a graph. Your range is your y values, okay? Bottom to top on a graph. All right, and then we just list them. Do not repeat, and list them in numerical order, smallest to largest. All right, bye guys.